Hello, friends, a podcast to get you ready for your Chapter 11 test. We began Chapter 11 building on what we learned about confidence intervals in Chapter 10. Remember that to build a confidence interval, we took a normal curve like so, and we put our sample statistic at the center of the normal curve, and then we added a standard error in each of these spots. And depending on how confident we wanted to be about capturing the population mean mu, we would go out and say 95%. So 95% of the area in here was covered. And so our 95% confidence interval was whatever this number came out to be. This is minus the margin of error. And this was plus the margin of error. Okay. And now when we get to Chapter 11, instead of starting with a sample statistic, we start with some assumption about the population, like the population mean. And we call that assumption the null hypothesis. So we're going to start by assuming that this is true, whatever this is, and then we're going to have some alternative hypothesis, which we test. So basically what we're finding is, what's the probability of getting whatever statistic we get, call it x bar, if this statement about u is true. So that's what we're doing. So you should know null hypothesis, you should know alternative hypothesis, you already know your three conditions, which are random, normal, and independent. You know all this. You know that if you're working an inference toolbox, that when you do the calculation section, you're going to put the formula that you use, you're going to show the substitution. It's also a good idea to write out what mu is, what x bar is, what n is, what z star is. If you have an alpha level, if you have a confidence level, whatever you have, write those numbers out in this form, and you show the form, the substitution, and the result, which you'll get off your calculator. Remembering that all your formulas are in your packet, and the substitution numbers are in the problem, and the results are going to come off your calculator. And then you got to be able to write these conclusions. In other words, take this result and write it in context of the problem. So let's just look at a couple quick. So let's look at 11.4. Remember, problem 11.3, the answer's in the back of the book, so you can check that one too. But we did this one in class. So if you pause and read the problem and take a look at what they're trying to do, you should be able to say that the null hypothesis is that mu is equal to 26 miles per gallon, and the alternative is that it's greater. And this is a mean problem because we've got a mu. In part B, this is a proportion problem, and we know that because we've got a percentage, and we also know that we got a b here, and we know this is a two-tailed test because of the word true. Rather than saying greater than or less than, it says or implies what's the probability would be this far above or this far below in my school. We went over a bunch of these. These are all in the notes on the website, 11.5. We went through a bunch of them. And once we got this hypothesis, we're going to get a test statistic. Okay, and these are written on the sideboard in the classroom. They're also in the packet. And the two types that we have are for means and proportions. And we've done hardly any T stars recently in class, so probably you're going to have Z statistic or a proportion, and all this should be familiar to you. Again, just reading through the examples is helpful, seeing how they generated statistic, what the Z statistic means, and then reading what they did, what they said about the p-value, and how they interpret and write and decide whether to accept or reject based on the Z statistic and the p-value they get from it. Remember, we looked at this example of the normal curve written with the actual numbers for the mean or written in terms of their standard z-scores. So they both mean the same thing, and the p-value is the area under the curve, either for the one tail or both tails if it's a two-tailed test.